Okay, guys, so this is question 5 of 9709, paper 1, May, June 20. And the question of a line is y equals to mx plus c. The equation of a line is y equals to mx plus c, where m and c are constants. The equation of a curve is xy equals to 16. Given that the line is a tangent to the curve, express m in terms of c. Okay, so we have we have a line and we have a curve. Okay, so we have a curve and a line. And we have been given that the line is a tangent to the curve. So something like this, the visual representation of this. So y equals to mx plus c, and then xy equals to 16. Yes, so I can make the y as a subject and then equate both of these to get the value of x. So y equals to 16 upon x. I'm getting this value of y and then this equation of y. So yeah, so I can just equate them. So it would be mx plus c equals to 16 upon x. This x would go there, so it would be x mx plus c equals to 16. This would be mx. Okay, this would be mx squared plus cx minus 16 equals to 0. Because it's a tangent, so I can say that b squared minus 4ac equals to 0. Yes, because it's a tangent. So what's b squared? It would be simply c squared minus 4a would be m. Okay, so the coefficient of x squared is a. The coefficient of the variable x of the variable is b, and the constant term is c. So b squared minus 4a, and then the c would be negative 16 equals to 0. So it would be c squared minus it would be plus 64m. Okay, 60, no, is it 64? Yes, 64. So 64m equals to 0, and then c square equals to c square equals to 6 minus 64m. So I have to express m in terms of c. Okay, so I have to make the m as a subject, so it would be negative c square upon 64. There. For part B, it is given that instead that m equals to minus 4, m we have been given the value of m, find the set of values of c for which the line intersects the curve at 2. Okay, so now for part A, the line was tangent to the curve. Now the line is intersecting the curve at two distinct points. For two distinct points, b square minus 4ac has to be greater than or equal to 0. So from our previous part, it was m equals to negative c square upon 64. We have been given m as negative 4 equals to negative c square upon 64. This negative will cancel out. 64 times 4 is 256. Yes. So 256 equals to c square. And then if I take root of 256, I will get 2 plus minus 16. Okay. So this was for b square minus 4ac equals to 0. But we have been given that the line is intersecting the curve at two distinct points. So it has to be b square minus 4ac greater than 0. So the curve is this, the line is this. Okay, so it is setting at two distinct points. It means this would be negative 16, this would be positive 16, of course. And because it was b square minus 4ac greater than 0, so how I'll get the value is greater than 0? Assume it as like m has to be greater than, for this was equals to, this was not equals to, right? This was what equals to, but for part B we have greater than, b square minus 4ac has to be greater than 0. So m is actually greater than c square over 64, negative c square minus 64, sorry. So c square is a curve. This was a curve of c square, okay? And because it has to be greater, so for greater, I can see that it has to be greater than 16. Okay, so if I get the value of m as value of c as greater than 16, okay, and this would be less than 16. So c would be greater than 16 and c would be less than negative 16. These are my final answer. I hope you guys get this. Thank you for watching this video, and please do share this with your friends, and please like and subscribe this video. Okay.